I wanted to go over this assignment that I gave y'all for law of sines, and just make sure we're all clear on how to use the law of sines. Now, so here we've got alpha equals, for this first one, 102.4 degrees, gamma is 16.7, and A is 21.6. So we got to find the other non-given parts. We got to find beta, and we've got to find B and C lengths. So I start off here, I'm going to find C. So notice what I do, I take C over gamma, sine of gamma, and set it equal to 21.6 over sine alpha. So I just use those ratios, solve for C, and I get 6.4. Now, at this, I could have done this next step first, but to find angle beta, I don't need to use the law of sines because I've got two other angles. And we know that there are 180 degrees in a triangle, so I can just say 180 minus the sum of the other two angles, and I get 60.9. Now, at this point, there's just one more thing to do, and that's to find B. So I set up my ratios, and I get that to be 19.3. So this is just straightforward. Now, notice I drew a triangle up here just to kind of keep things straight in my head. It's something that helps me, but it's by no means to scale. It doesn't match the numbers we're given. It's just for me to, see where things are. I don't know why it helps me, but it's not supposed to be to scale. Okay, now the next one, same thing. This time, I'm given basically the same situation. I've been given alpha and beta this time instead of alpha and gamma. So you go through, work this problem the same way using those ratios. Now, the next three problems, we have the ambiguous case. Now remember, with the ambiguous case, it's a side-side angle thing. You've got an angle, and then a side, and then another side. It's not side, angle, side. It's an angle, and then a side, and then another side. So notice, in this case, let's just see what we've got here. How do we know it's the ambiguous case? Well, I've got beta. Okay, here's beta. And then I've got side A. Okay, that one. And then side B. Look at that. That's angle, side, and side. Now, so that tells me I've got the ambiguous case there. And really, I just proceed to work it like usual, just using the law of sines. And I work through it, and I get the missing angles. I get alpha and gamma. I get the missing side C. And then I'm ready to determine, well, is there two solutions? Now, I gave y'all a way that you can test this. And in this case, notice I have been given beta and B, and I've been given A. The way you can test if there's two solutions is if this inequality holds. If A sine beta is less than B is less than A. Notice how this beta and B are right next to each other. And A are like the bread of the sandwich. If that inequality holds, now this is because we've been given beta, sine, angle beta, and we've been given side A and side B. And we're going to see how this is modified a little bit when we're given alpha and side A and side B. But anyway, I put this ratio together, and I notice that when I plug this in, I get 1.2, which is less than 6.8, but 6.8 is not less than 4.5. So that inequality doesn't hold, so that means, thank goodness, there's only one solution. So we can move on. Now the next one, we see, okay, this too is the ambiguous case, but we don't pay that much attention. We just go about our business to solve this. It looks like I need to find angle beta. So I've got sine beta over 200 equals sine 110 degrees over 125. And when we work that out, we get sine beta equals 1.5. Ah, that can never happen. Sine beta can't ever equal anything bigger than 1 or anything less than -1. So right away that tells us, no, there's no solution. Now, if you forgot that and you punch in your calculator, beta equals inverse sine of 1.5, your calculator will let you know, okay, yeah, that's an error. Okay, so there's no solution there. Now, let's look at the third one. Now, this one, remember, we're going to use this b sine alpha is got to be less than a, less than b, if there's to be two solutions. When we work this out, there we find that, yeah, that inequality holds, so that tells us there's two solutions. So we just go about our business working this out, and after we get the first triangle, after we find the first triangle, solve the first possible triangle from this information, from that given angle, alpha, from the side 9.5 and b is 22. Once we're going to find one triangle, we're going to solve one triangle. We don't care which one we're starting with, we just go about solving it. So I've got sine beta over 22 equals sine 25 over 9.5, and I get beta is 78.2. Okay, and then I find gamma, and then I find c. So I'm just going about my business using the law of sines. I've got one triangle solved, but there's another one out there lurking. I've got to find that one. So we need a place to start on that one. I was given alpha, A, and B. Now, here's where we start. Here's where we transition to the new triangle. Notice I was given alpha and its opposite side. I was given B, but not its opposite angle. That's where we start. The first thing we do is go to the angle opposite the side, the angle that we weren't given, opposite the side that we were. And that happens to be beta. So the very first thing we do is we come over here and we say beta prime equals 180 minus the previous beta. That's where we start. And when we do that, we get 101.8. Then I can get my new gamma because I've got my new beta. So I've got 180 minus 25 degrees plus 101.8 degrees. Now, by the way, I'm using 25 degrees, and really it's like 25.06 degrees or something like that. And I just decided for simplicity to illustrate how this process works, I would just call it 25 degrees. So anyway, that's why I'm working with 25 degrees here. But remember, the way you convert that degrees, minutes, and seconds to decimals is you say 25 plus 4 over 60. And that would give you the decimal representation. Then we find C prime, and we find that to be 18. So that's how you deal. These are just typical law of sines problems.